Hello everyone, welcome back to the brand new series for UPSC Mathematics Optional. As I promised in the last session that before starting with the vector spaces, I'm going to take you from geometrical representation of vector to the mathematical representation, that is matrix representation. Alright, so to keep my promise, I'm here. Let's begin with the topic. So from the memories of 11th standard, we know if we are representing a vector, right? So let's draw a graph here. We find that we can represent a vector geometrically by an arrow, right? The length of the arrow tells us the magnitude and its tip tells us the direction, right? So let's say the coordinate of tip are 3, 2 here, and definitely we know coordinate of origin are 0, 0, right? Now to represent this vector in matrix form, what we do, we lose these 0, 0 origin, right, and keep only the coordinates of tip, right? So let's say we keep these 2, 3. So here let me indicate the point, just a second. Yeah, so it is 3, 2. This we call as row vector. All right, and here this particular we call column vector. Okay, so you can notice I'm placing the arrowhead here, but I'm not placing arrowhead here, because this information in itself carrying that particular arrowhead information. All right, it is a vector. Okay, so if we are going to increase the dimension, then it will become a tensor. All right, so we are not going there. Our topic is to just make a basic understanding that how a geometrical representation of a vector can be translated to the mathematical representation. So let's say we have another vector. Let's say B, and its coordinates are 1, 3. So guess what is going to be the matrix representation of this? Sure, it's going to be 1, 3, or in column vector it's going to be 1 by 3, this way. It's not by 3, 1, 3. All right. Okay, so for we can start with any one, like we can start with row representation, we can start with column representation. So for now, let's keep the row representation, and then we'll continue while discussing problems and while discussing the actual concept, that is actual syllabus. We'll continue with the requirement, whether it is demanding with a column or demanding with a row. We'll deal with that. Okay, so we have done this representation. Now think of a vector that is going from tip of this to the tip of B, right? Let's say this one here. Okay, this one actually. Now the C vector, as we know, it is going to be the subtraction of vector A from vector B. All right, so it's going to be the represented in this is sometime we call Cartesian representation. It's fine, right? So it is represented by minus 2 I cap plus j cap. Now if you want to represent this vector in matrix form, guess what you can do? Definitely it's minus 2, 1. Very good. Now think of if this vector we want to represent, like here with A and B in the last slide, you notice that both of them are having their tail at origin, but this particularly is not having tail at origin. So how to represent it this way, right? This must be the question. Well, if you remember that we can translate a vector, right, and the vector remains unchanged, the condition is we need to keep the direction constant as well as its magnitude unchanged, right? Then only we can translate a vector. So let's say if we are able to translate it, suppose let's drop these A and B, right, and translate this vector to the origin. Okay, now look at the tip. Definitely it's minus 2, 1. Now it's the same representation of A and B, if you noticed, isn't it? Yes. So definitely we can represent this in this particular format, that is C equal to row vector, that is minus 2 and 1. Okay, that's enough for 2D. Let's jump to the 3D board. So here, as you know, representing a 3D concept in 2D becomes a bit tricky. So here, to just kind of have a look, I'm trying to draw the 3D plane so that you can imagine, okay, this A is in 3D. All right, now let's say its coordinate tip of this vector A, 3, 2, 2. Now we want to represent that in the row vector format. It is going to be represented this way, isn't it? Right, as with the previous concept, we definitely can represent this way. Okay, now suppose we are going to increase number of terms in row vectors. Here you can see in previous slide there were only three, that is 3 elements, that is 3, 2, 2. But here we have another element, that is 4. What to do now? Can we represent this vector in this way particularly? Well, if we are going to represent this particular format, it is going to tell you only about 3 points, that is 3 elements, that is 3, 2, 2. What about 4? It's not possible to represent the 4D vector in 3-dimensional geometry, right? So here you noticed is the limitation of 3D visualization, right? And to overcome that, what you can do is just throw away this 3D visualization concept and continue with this particular matrix representation, that is row or column representation. Okay, so as this particular vector, we can say it's A4, the vector of 4th order. All right, it's fine. Similarly, you can see if we have, this is a mistake here, it's n, right? Instead of 3, there must be n. Okay, so it's an n dimensional. So you can say it's going to be 1 cross n, because 1 row in n columns. All right, so this is what the matrix or row representation or column representation of a vector. Why I was kind of emphasizing these points here, and why I was why I'm here to discuss this representation, because in vector space particularly, you'll find that we are dealing with only this particular representation, right? So whether we are talking about basis vectors, whether we are talking about spanning of a vector field, that's going to utilize this either row or column representation, because otherwise the geometrical representation going to put some restriction on us that we can't go beyond 3D, right? So here you can see in this particular vector, it's up to n. It's not possible to visualize in 3D, right? So that's why I was kind of trying to emphasize on this particular area, to go from geometrical representation to the matrix representation. Okay, so this is it for the geometrical representation, and basically going from geometric to matrix. Now we are going to study some prerequisites of the vector space. Okay, so see you in the next slide.